On the shark bite, show me which number or numbers you would like to see, do, go over, have questions about. If you were 1, raise your hand. If you were 2, raise your hand. 2, that's a lot. 3, 4, okay, and 5. So there were a lot of 2s and a good amount of 1s. And I'll pick one of the other ones. Just trying to remember who. Let's do 5 and 2 and 2 and 5 and 1. We'll do those. Okay. For number 1, you needed to distribute. We have negative 16 minus 14x minus 21 equals 23 minus 2x. Combine your like terms on the same side. So we have negative 37. Looking at just this, when you solve it, we're going to get one solution because we have different coefficients. How you choose to move things is up to you. But if we added 14 and subtracted 23, we would get negative 60 equals 12x. So that negative 5 equals x. So if you got negative 5, good job. If you didn't, just go back and fix it. You may have forgotten a negative somewhere or added or subtracted incorrectly. Questions on that one? Number 2, we had to evaluate. So put these 2 in for m and n. Remember that evaluating absolute value is different than solving absolute value. With evaluating, you do what's on the inside first. So this would become negative 9. This would become a positive 9 because of the rules of absolute value. And then we could multiply. And then number 5. The slope from this, we need to solve this, convert this back to slope-intercept form by subtracting 2x on both sides. And dividing everything by 5. And then from this, figure out which number would be the slope. Which of these would be the slope? Negative 2 over 5. Questions on that one? We are going to finish our graphing notes. And then once we finish that, we're going to move on to something else. So go ahead and take those out. Let me know if you need another copy. So just to recap, we talked about graphing by slope-intercept form. graphing when it's not in slope intercept form, when it's in standard form, converting it back. Graphing horizontal and vertical lines. And now we're going to talk about graphing by intercepts. So this is similar to when we were solving intercepts in this format. So we don't need to convert it. We don't need to put it back in slope intercept form. It should be in standard form for this. I'm going to write these rules, steps, and then talk about the actual math behind it. So cover up the y term and solve for x. Cover up the x term and solve for y. This would be like when we were solving for these intercepts and we put 0 into the y term. So to cover up the y would be putting 0 into y. This would become 0. And then we just write everything that's left and solve. Or the cover of the x would be putting 0 in for x. This becomes 0 and writing everything else and then solving. When we graph by intercepts, we are not graphing by slope. So you should only have 2 points on these, your x and y intercept, and that's it. So we are not putting in the 0 part. We're skipping that part, so we're showing less steps. So we can do that when we're graphing, but when we're solving for intercepts, we have to show all the steps. So for this one, if we were covering up the y term, what would be left is just 3x equals -6. And we would solve that by dividing both sides. And then you would plot that as a point on the x-axis, -2. Then you would do the same thing for the y, so cover up the x term, and we'd have -2y equals -6 left. Divide both sides by -2 to get y equals +3, and plot that point. Then you would draw your line through those 2 points, and that's it. So these will only have 2 points. You should not have more than that. So when you get to a graphing problem, if it says specifically to graph by intercepts, this is what you would do. If it doesn't have directions and it just says graph, you can choose whether you want to convert it back to slope intercept form and graph multiple points or graph using your intercepts. The intercepts works best if both numbers in front of x and y are factors of this number, or can be divided into that. Questions on this process? Let's try another. So for number 2, if we were covering up the y term, what would be left? X equals 4. That's it. There's no work. You would just put that and plot the point. But for the other one, if we were covering up the x term, what would be left? 2y equals 4, and you would divide both sides by 2. And plot that point at +2. And then graph that one. If you want rulers, you're more than welcome to grab those. Look at numbers 3 through 6 on this page and 7 through 10 on the next page. Are there any others we want to see you go over and have questions about? couple minutes to try a few, and then we're going to move on to something else. Were there any that we wanted to go over, double check the answers to, anything like that? Okay, so this is the last lesson that we need to cover, and we won't get through everything today, but we'll get through a good majority. So we've talked about slope and all the different ways to find it, x and y intercepts, how to find it on a graph, and algebraically, how to graph in different ways. This is kind of tying some of those things together, but in a different way. Before we can actually do what's necessary, there's some background information that you need to know, but I don't have a specific spot for you to put it, so you can either write what I'm about to write at the top or at the bottom of this page. So this last lesson is about transformations, how the graph moves or changes compared to the original. We'll talk about that in a minute. There are 3 transformation words we need to be using / know. One is shifted, up or down, steepness, and we'll talk about that, and then reflective, or reflection. So 2 of those are for your slope, 1 of those is for your y-intercept. So we'll talk about the y-intercept one first, because there's only 1 of them. So for your y-intercept, your graph can be shifted, up or down. So when you hear the word shifted, you should be thinking y-intercept. When you think about the y-intercept, you should be shifting up or down. Depending on how it looks, this is also adding or subtracting. So anytime you see something being added or subtracted, you should be thinking about your y-intercept is changing. It's being shifted. All those things go together. Okay. For the slope, there's the other 2 things. So one of the things with slope is it's reflected. And this, and I haven't wrote this down yet, but when we're comparing it to the original, which we'll see in a second, if the slope is negative, it's been reflected. So anytime we have a negative slope, we can say it's been reflected. And then there's the steepness. Slope can either, compared to the original, be steeper, or it can be less steep. If it's steeper, the slope is steeper, the slope is going to be greater than 1. So 2, 3, 4, keep going. So I'm going to put m is greater than 1. And then if it's less steep, it's going to be a fraction, less than 1, but not a negative. So between 0 and 1, I'm going to say 0 less than m less than 1. That means between 0 and 1. So basically, if it's a fraction, where the numerator is less than the denominator, it's going to be less steep. These 2 things have nothing to do with each other. It could be reflected and steeper. So the number and the negative are 2 separate things. It could also be less steep and reflected, or any combination of those. Okay. And then the other piece is, with slope, it's usually multiplying or dividing. So that was a lot of background information. Now we're going to actually put it to use. So with all of those things, we need to be able to take those and describe whatever function or graph or whatever is given, as well as graph and describe. So we're going to be doing a mixture of all of those things. So in number 1, oh sorry, I forgot to write one more thing. The original that I talked about. So all of these functions, graphs, whatever, are always comparing to the original, which is f of x equals x, or y equals x. What would the slope be for this, for your original? What's the number in front of x?
2, 1.
1. For this one. And then what's your y-intercept? There's nothing there. So it would be
0.
0. So every time we talk about these, we're describing, we're graphing, whatever, we're always comparing to this original, where the slope is 1 and the y-intercept is 0. So for number 1, we have some function that's being added by 2. Adding and subtracting, that's your y-intercept. So something about your y-intercept is changing. So we can say the y-intercept is shifted. Now if it's adding 2, is that shifting up or down? Up. So the y-intercept shifted up 2. So you have to say what you're talking about, the y-intercept of the slope, what it's doing, shifted, in what direction, up, and then by how much. We also have to talk about the slope. Now, nothing here is related to the slope. That means the slope has stayed the same. So no matter what is being talked about, we have to talk about both, the y-intercept and the slope. What changed? What happened? Did it change? Did it not? Do we have any questions so far? Okay. So then in number 2, what do we think changed? The slope did, because we're multiplying this way. Now, these are 2 separate things. It has a negative, so that means what about the slope? It's reflected. So we can write this as 2 separate sentences or as one sentence with 2 things. It doesn't matter. So the slope was reflected. And then this 1/3 talks about the steepness. Would that be steeper or less steep? Steep. Less steep because it's a fraction. So you could say the slope is less steep by 1/3. There are actually different ways to say this. Slope is less steep by 1/3. Slope is less steep by a factor of 1/3. Slope is 1/3 less steep. Any of those would be okay. Now, what about the y-intercept? Did anything change with that? Do we see anything that added or subtracted? No. So the y-intercept stayed the same. Do we have any questions so far? For the next couple, we're still going to describe, even though it doesn't ask us to, just to get in practice with describing. So in f of x minus 3, what happened? What changed? The y-intercept, what about it? I didn't mention this, so I'm going to mention it now. Tomorrow, you have multiple delta maths that are due, your slope part 1, part 2, x and y intercepts, and graphing. And then you don't have a delta math on this, but you do have a practice on this. So if you go into Canvas, there's an assignment called linear transformations. There are 2 choices on it. You can either do the Desmos activity, or you can do the Go Formative activity. No matter what, after you do either or, you need to email me so that I can double check it and grade it for you. But keep that in mind, that is also due on Friday, tomorrow. Okay, back to this. So we talked about the y-intercept. Did the slope change? No, it stayed the same. So we can say slope stayed the same. Right? And then in this example, we are graphing, but we are only plotting 3 points. It says to create the graph of the line, but we're not actually creating the line. We just need to plot the 3 points. So if the y-intercept shifted down 3, this is our original that is drawn. If it was at 0, 0, and it's been shifted down 3, where's our new y-intercept? At -3 on the y-axis. So your y-intercept is always going to be one of your points. If the slope stayed the same, think about the slope of this line or your original 1 over 1. So you just need to plot 2 other points. Where you plot those 2 points is up to you. If you want to go up 1, right 1, down 1, left 1, those could be your 3 points. If you want them further spaced out, you could do that. If you want to go more to the right, you could do that. If you want to go more to the left, you could do that. You just need 3 points. We should not be putting more than 3 points. We also should not be graphing, because it didn't ask us to. Okay, questions on that? So what changed with this one, number 4?
Slope is reflected.
So not reflected, there's not a negative.
Oh, it's more steep.
It's more steep or steeper, yes. So just like less steep, you could say steeper by 2, steeper by a factor of 2 is 2 times as steep. Any of those apply. What about the y-intercept?
Stay the same.
Y-intercept stays the same. Right, so when we go to plot our 3 points, the y-intercept stayed the same, so that means it's going to be at the same place at the origin. And then if the slope is steeper by 2, where could I plot another point? Or what would my slope be?
Wait, is it 2 over 1?
It is. So any 2 over 1 from the y-intercept, we could do up 2 over to the right 1, down 2 to the left 1. Sure. We could keep going to the right, we could keep going to the left. It doesn't matter. You just need 3 points. Questions on those? Right. Now, with number 5, it's a little different because now they're giving you equations and you have to describe them. So you have to know a couple things. What is it asking us to describe? So here we have our original, and here is our new equation. If this is talking about shifted up or down, which one is that talking about? Y-intercept or slope?
Y-intercept.
Y-intercept. So if we're comparing the y-intercepts from the original to the new one, what happens? Did it shift up or down?
Up.
Up. And why do we think up?
It's addition.
Because of the plus 7. Okay? Now, if the first one was y-intercept, then this one is slope. We're comparing the two slopes. Did this get steeper or less steep?
Less steeper.
Less steep. How do we know that?
Because it's a fraction.
Because of the fraction. And not just because it's a fraction, but specifically it's a fraction where the numerator is less than the denominator. It could be a fraction like 3 over 2, but that would be greater than 1, because that would be 1.5. So keep that in mind. If it's a fraction with the numerator less than the denominator, then it is less steep. Okay. Questions on number 5? Go on to the next page. After we finish this page, we will stop for today. Now, these are similar questions, so this should move a little faster now that we know the words. So number 1 and 2 on this page is asking us to not only describe, but also graph the line. So this one, we have to graph the line, not just a couple points. So what happened in number 1? What changed? The slope. What about it, Isaiah?
Reflected.
The slope reflected. Was that the only thing?
It's less steep
Less steep?
by 3.
So just the 3 is the steepness. So would that be less steep or steeper? Steeper. So the negative has nothing to do with the 3 when you talk about steepness. Okay. What about the y-intercept? It stayed the same. Okay. So if the y-intercept stayed the same, we're going to plot it at the same place at the origin. If the slope was reflected and is steeper by 3, what is our new slope? 2. Yes, but in which direction? Would I go up 3 and right or left 1? Up 3 and left 1 as many times as possible. And down 3 and right 1 as many times as possible. Make your line. So when you have a fully graphed line, you can really see the steepness. I'll give you a second to finish your line first. When you have your line graphed, if I were sledding or skiing or skating or something down these lines, which one would you get down faster? The blue line or the original? The blue. So you could say it's steeper because of that. All right, let's do number 2. What changed in that one?
The y-intercept.
What about it?
It shifted by 2.
Yes, the y-intercept shifted up 2. What about the slope? Slope stayed the same. So where would our new y-intercept be? At positive 2. Our slope stayed the same, so it was 1 over 1, so we're going to plot a bunch of up 1 over 1 points. And down 1, right, down 1 left 1. When the slope stayed the same, you could also say the steepness didn't change or the steepness stayed the same. because you would get down these at the same rate. Questions on that one? Right. Number 3, if the graph of g of x, or this function, is it shifted up or down compared to the original?
Down.
Down. How do we know that?
Because it's -4.
Because of the -4. And then is this steeper or less steep? Less steep. How do we know that? Because the fraction that and it's the numerator is less than the denominator. Okay. Number 4 is describing it in a different way. Now it actually says, this is talking about the slope, this is talking about the y-intercept. The graph is your new function. If you want to put your original function up there, you can do that. I'm going to do that just so you see it visually. There were some typos in some of the answers. So if we were comparing the slope of the original, the one that was already graphed, the original, the one I graphed, to the new one, the one that was already graphed, which of these would apply? What is the slope of the new function, the one that was already graphed? 2/3. So the only one that has something about 2/3 is B. C and D could not apply because these are adding and subtracting. Slope has to be multiplication or dividing. So what about the y-intercept? Comparing the original to the one that was already graphed, which of these would apply? Is it 3 more than? Is the new 3 more than? So C. Again, A and B could not apply because y-intercept is adding and subtracting. Always remember that you're comparing the new to the original. What changed from the original, not the other way around. Okay. Questions on 4? Okay. And then 5 is kind of a mixture of some of the things we already did. We have to plot 2 points. So this says a line will extend through the 2 points. That's if this were a SOL question. You would plot the 2 points and then a line would extend through it, but we don't need to graph the line for this one. So if our new function is shifted up 5 units, where's our new y-intercept? 5 on the y-axis. And if it's 1/2 as steep, what is our slope? 1/2. You just need 2 points, so you can choose which direction you want to go. Up and to the right 2, down and to the left 2. Don't do more than 2 points. Do we have any questions on anything we've done so far? So I'm going to give you options to practice to work on. So you can either work on your delta map and linear transformations. That's due tomorrow. If you want more graphing practice, I don't remember if you guys did this or not, but I'll put the graphing and killing zombies back out. Or you can keep working through your graphing notes. So So one of those three things, you should be working on one of those three. You finish one, move on to the next one.